You've written a function that calls a database, which calls an API, which calls another service. The original HTTP request times out. How do you stop all of those downstream operations? Without a shared mechanism, you can't. Each layer has to invent its own cancellation signal. Go's answer is the context package, a standard interface that every library in the ecosystem accepts, so a single cancel call can propagate through the entire call tree. This episode covers context from root to leaf. The context interface carries 4 things. A deadline, when the operation should be done. A done channel, a channel that closes when the context is canceled or times out. An error, nil while running, then either context canceled or context.deadline exceeded. And an optional value map for request scope data. Every blocking operation in the standard library takes a context as its first parameter. http.newRequestWithContext, db.queryContext, os.readFileContext. That's intentional. It means any of these operations can be canceled with the same mechanism. You never create a context directly. You start with a root context background for main programs and tests, and derive all other contexts from it using with cancel, with timeout, or with deadline. Each derived context is a child of its parent, and canceling the parent cancels all children. Context.todo is the other root context. Use it as a placeholder when you're refactoring code and you know a context should be plumbed through but haven't done it yet. It signals to the reader, this needs attention. Context.withCancel returns a child context and a cancel function. Calling the cancel function closes the context's done channel, which signals every goroutine or function holding that context to stop. The most important rule, always defer cancel. Immediately after calling with cancel, with timeout, or with deadline. If you don't, you leak the internal goroutine and timer resources that Go uses to track the context. This is one of the most common context-related bugs in production Go code. Inside a function that does work over multiple steps, a loop, a sequence of operations check CTX. Done with a non-blocking select. The default case handles the not yet canceled path. When the done channel closes, the case CTX done fires and you return CTX error. That error flows back up the call stack until it reaches code that knows how to handle it. Contexts form a tree. Every with call creates a child of the passed-in parent. When you cancel a parent, every child in the tree is canceled simultaneously, no matter how deep. This is the feature that makes context powerful for production systems. An HTTP request arrives. You create a context with a 5-second timeout. You pass that context to a DB query, which you wrap in its own 2-second timeout. You pass the same context to an external API call with a 3-second timeout. If the HTTP request is canceled because the client disconnected, all 3 operations stop. If the 5-second HTTP timeout fires, all 3 stop. If the DB query times out, only that branch stops. The API call continues. Children can have shorter timeouts than their parents. The effective deadline is always the minimum of all deadlines in the ancestry chain. A child context cannot extend its parent's deadline. When writing workers that should stop on parent cancellation, range over CTX. Done in a select, the moment the root context is canceled, every worker detecting CTX. Done exits cleanly. Context. With value threads metadata through a call chain without adding it to every function signature. The canonical use cases: request ID for logging and tracing, authenticated user ID for authorization checks, tenant ID in multi-tenant systems. The key must be a type that won't collide with keys set by other packages. Using a plain string or int is dangerous. Another package could use the same key string and overwrite your value. The idiomatic fix: declare a private unexport type in your package and use values of that type as keys. Because the type is unexport, no other package can create a value of that type and collide with yours. Wrap the with value and extraction calls in helper functions. This keeps the type assertion in one place and gives callers a clean, typed API. With user ID, CTX, 42, and user ID from context, CTX. No raw CTX. Value, calls scattered throughout the codebase. The key limitation. Context values are any under the hood. The compiler can't type check them. Every extraction requires a type assertion. This is why context values should be used sparingly, for cross-cutting metadata, not for ordinary function parameters. A cancelled context doesn't automatically stop a running loop. The loop keeps running until it finishes or panics. If you have a loop that processes 1,000 items, and the context is cancelled after item 2, items 3 through 1,000 will still run unless you explicitly check. The pattern is a non-blocking select at the top of each iteration. Select with a default case is non-blocking. If CTX done is closed, the case fires and you return. If it's not closed, default runs and you continue to the next item. CTX error tells you why the context was cancelled. Context cancelled means someone called cancel explicitly, probably a higher level decided to abort. Context.deadline exceeded means the timeout fired. This distinction lets you log different messages or return different HTTP status codes depending on the cause. HTTP handlers are where context becomes essential in day-to-day Go. Our .context returns the request's built-in context. The Go HTTP server automatically cancels this context when the client disconnects. If the browser navigates away or the connection drops, the handler's context fires. Chain your own timeout on top. Context with timeout or .context 5 time second. Now the handler is bounded by both the client disconnect and the server-side timeout. Every downstream call, DB, cache, external API, receives this context. If any layer returns because of context cancellation, you check CTX error at the handler level to decide the right HTTP status code. This is the standard production pattern. The context threads from the HTTP server through the business logic to every external system, and cancellation propagates automatically in all directions. Context as first parameter is a Go convention so universal that Go vet will warn you if you put it elsewhere. Every function that does I/O, calls a network, or might block should accept a context. Context as its first argument. This is non-negotiable in library code. Callers expect it. Never store a context in a struct. Contexts are request scoped. They represent one operation, not an object. If you store a context during construction and use it in a method later, you'll be using the wrong context for that later request. The fix is always to accept a context in each method that needs one. Use context values only for request-scoped cross-cutting concerns. Request ID, auth token, trace ID, things that need to be available deep in the call stack without threading through every signature. Not debug flags, not configuration, not database connections. Those belong in explicit parameters or struct fields. Every cancel must be called. Every with cancel, with timeout, and with deadline allocates resources. If you forget to call cancel, those resources leak until the parent context is eventually canceled. Defer cancel immediately after creation is not a style preference. It's a correctness requirement. Context propagates cancellation, deadlines, and request scoped values through call trees. Root contexts, background, and to-do. Derived contexts, with cancel, with timeout, with deadline, with value. Always defer cancel. Pass CTX as the first parameter. Never store it in structs. Use typed keys for values. Check CTX done in loops. Use CTX error to distinguish cancellation from timeout. Next episode, Reflection, goes runtime type introspection. This course is based on the complete guide to Go programming. Available on Apple Books and Amazon. Find it at pixelstech.net/book. See you in episode 22.